you it's a very popular talk, so try to register now for the event.
Oh, thanks.
Okay, so shall we start? It's really our honor to have invite speakers to give us two talks. So we have Dr. Amy Jones from the UK and also Jorge Valento from Guatemala. It's going to be very interesting in today's talk because obviously UK and Guatemala, their development are kind of in different stages. So they have different issues in environment, and also but they both of them talk about try to engage citizens to be involved in the environmental protection. Okay, so and then they're going to introduce themselves. I'm not going to repeat here. So let's welcome Dr. Amy Jones.
Great. Yeah, I'm really excited to be here today. So thank you to Lipen for inviting me, and also thank you to Isaac and Lydia who've helped with all of the IT, which I'm so grateful for. Thank you. So yeah, the title of today's talk is How Can You Help to Make Rivers Healthier? So I'm going to start just by introducing myself and the company that I work for, which is called WRC. The talk's about river health, so I figured a good place to start would be explaining what I mean by that. Give you a very short history lesson about river health in the UK, and then talk a bit about how we analyse river health in the UK at the moment. And then finally, we've been working on a few projects with NTU, and they've been fantastic. And I think the things that you're learning on your course are absolutely brilliant and are really going to help us to advance understanding of river health and maybe do things in kind of better ways than we do at the moment. So yeah, at the end we'll talk about a couple of the projects that we've been involved with. So yeah, a bit of a challenge for you today, and something I want you to kind of think about as I'm talking is that, are you laughing at how old they are? Or so the current analysis methods that we use in the UK that I'm going to talk about today, a lot of them are like 30 to 40 years old, so I think older than a lot of the students in the room probably. And I think what you're kind of doing on your course, how can that use of computer-aided civil engineering make us smarter? How can we do things better? So, throughout the presentation, I've tried to pick out different... by the way, if I speak too fast, can someone do this? Too fast? Okay, thanks. I'll go slower, calm down. So throughout the presentation today, I've used this colour pink to kind of highlight bits of data that we use to understand river health in the UK. So when you see some pink words, I want you to think kind of, oh, what's that data? How would I analyse it? How could I use it to understand how healthy a river is? So yeah, look out for the pink text. So there we go. Yeah, if anyone has any questions, so we'll go 2 hands if I'm too fast, 1 hand if you have a question. There's a Slido set up as well, so if you want to type any questions in there, that's fine. Oh, yeah, of course. Oh, is it not on? Oh, yeah, it's red. I should have worked that out. All good? Oh, it's loud. And yeah, if maybe you're a bit quiet or shy, if you prefer to ask questions later, my email address is there and I'm happy to take your questions afterwards. So there we go. So yeah, a bit about me to start with. So I think like a lot of you, I'm doing I did a civil engineering degree from 2003 to 2007 at the University of Sheffield in the UK. When I was a civil engineering student, which is like in 20 years ago, we did subjects like soil mechanics, structural engineering, hydraulics, mathematics. There wasn't so much, machine learning wasn't really a thing. We didn't really weren't really aware of it, I guess, back then. So yeah, that's why I think your course is so interesting. After that, I went on to do a PhD at University of Warwick, also in the UK, and that was about kind of how pollution or pollutants move through sewer networks, so how they spread out and get less concentrated. But you can ask me about that separately. I won't bore you with it today. And then after my PhD, I went to work in industry. So I worked for a company called RPS with Susanna. And to start, I was a hydraulic modeller. So later on, I'll talk a bit about what that involved. And at the end of my time at RPS, I was a technical manager. So managed like a team of 10 to 12 people. My work at RPS, we helped water companies to decide where to spend money, basically. So where there were problems with pollution or flooding or impacts of climate change, where should we spend money to try to solve those problems? Towards the end of my time at RPS, I started to work on 1 or 2 more research-led projects, and I remembered, oh yeah, that's what I really love. So in March this year, I joined WRC, so that's where I'm a senior consultant at the moment. I think the contact details will be like a hyperlink, and I can share the slides afterwards, so yeah, all good. So yeah, that's me. So yeah, as I said, I work for Water Research Centre Limited, which is mainly UK based. So we've done research-led work in the UK for almost 100 years. So it's been going for quite a long time, this company. I won't go through all of the history, but anyway. And we sort of provide consultancy services to regulators. So in Taiwan, I think that would be like the Environment Protection Agency and the Water Resources Agency. So that's what kind of similar, but in the UK. Municipalities, so that's like a local authority, so I guess Taipei city government, similar? Okay, getting some nods. Utility providers, so that means the company that provides water and takes wastewater away, and then their supply chain, so people who help the utility providers. Most of our work is in the UK, but we're growing internationally, so the last few weeks I've been doing a project in Oman in the Middle East. We've got some kind of new work in New Zealand, so we're slowly spreading from the UK. And yeah, we have 200 quite specialist technical staff covering like this whole range of topics. So I won't go through them all, but to give you an idea of the range, we have a team who are setting new standards for microplastics, so trying to understand the impacts of microplastics on human health and the environment and how we can assess that more. And then we have part of our business takes new devices that people have developed and sort of tests them and certifies them. So that's kind of some of the things that we do. Okay, so yeah. The talk today is about river health, so I thought it might be helpful to kind of explain what we mean by that. So fundamentally, it just means, are the fish happy? Is my basic definition of it. So does it help to keep, if you've got a healthy river, it allows the whole ecosystem to thrive. So all the plants, the animals, everything is happy. So I've been in Hualien the last 2 days, and I found these happy fish that I took a photo of that I thought kind of illustrated what I meant. So there we go, that's my definition of what it is. But if you want a more kind of official definition, we have a piece of legislation in the UK called the Water Framework Directive, which was established in 2000. And that sets sort of specific targets for what it means to make a river healthy. And the targets cover lots of different things. So we look at, can I move away from this? Can everyone hear me?
Yes.
If I go over there? Yeah, that's cool. So biological quality means is there a good range of fish species, it's kind of insects, I guess, and different plants as well in the river. So kind of assess what life is there. I can't say this word in English, so I think it's okay, but hydromorphological quality, which means is the river natural? Does it kind of flow naturally, or does it have lots of kind of concrete walls in it that stop animals moving freely? So we also assess, that's that end, hydromorphological quality. We look at the physical and the chemical quality, so look at measures like temperature, how much oxygen is in the river, what nutrients are there, so like nitrates and phosphates. And then finally, the chemical quality. So there are some chemicals that are really toxic to animals, and there are certain amounts of those chemicals that we're not allowed to exceed. So that's the not official definition. That's the kind of more official definition of what river health is. And you remember I said before about the pink words are like types of information we have about river health, types of data. So there's a few kind of examples on that slide. So I guess maybe it's similar in Taiwan to the UK, but in the UK there's lots of things that go into a river and things that get taken out of a river that can affect whether it's healthy or not. So we have industry discharges, so factories can put flow into the river. Agriculture, so farming, can have an impact. Drinking water, so sometimes water gets taken out of the river and then it's treated for people to drink. And then from urban areas, so cities and towns, we get like wastewater treatment works, untreated runoff from roads, which, yeah, lots I could say on that, but I'm aware I have 40 minutes, so I'm trying to keep to time. And then storm overflows. So the next slide I'll explain what storm overflows are. But for a factory to put something into a river or for a company to take water out for drinking, in the UK they have to have like a special license or permit, which sets like a concentration and a volume. So that's kind of some more information we can use to build up a picture of what the impacts are on a river, I guess. Right, this is where it might all go wrong and I might need Isaac's help for that. It might be okay. But I mentioned storm overflows. Oh, there we go. I'll just let you.
Storm overflows play an important part in the sewerage system, but they can impact on the quality of our rivers and seas if they spill too often. What are storm overflows and how do they operate? Combined sewerage systems take away rainwater runoff and wastewater, including sewage, in the same pipe to a sewage treatment works. During heavy rainfall, pipes can be overwhelmed by the volume of water, causing wastewater to back up and flood people's homes and businesses, as well as roads. To stop this happening, storm overflows act as relief valves to ensure that excess rain and wastewater is discharged into rivers or the seas. As they only operate during heavy rainfall, any pollution is quickly dispersed as rivers will be full and fast flowing. Climate change, population growth, and more urbanised areas are leading to more intense rainfall, more runoff, and more sewage. All of these factors increase pressure on the sewerage system. The Environment Agency sets strict protective permits to limit the impact of storm overflows on the environment. If permits are breached, then action will be taken against those responsible. The Environment Agency uses data to help improve the environment and has driven a programme to install monitors on all storm overflows to identify how often and for how long they discharge. This is called Event Duration Monitoring, EDM. The data gathered is used to identify storm overflows that are spilling too frequently so that action can be taken by water companies to stop this happening. This data is now available to everyone on gov.uk and water company websites so that progress in reducing their use can be tracked. What can we all do to reduce the impact of storm overflows?
That should work. Was his accent okay? He has a very strong accent. Everyone was all right with it. Good. Just go on to the next slide. Sorry.
Storm overflows play an
do I need to do this one? Sorry, this is why I need Isaac. Thank you. Storm overflows are they're really, I was going to say popular, but that's the wrong word. Big issue in the UK at the moment. So in the news in the UK, lots of people are complaining because they're not happy about these storm overflows and the impacts that they're having on rivers. So kind of continuing the theme of the talk, this is another type of data or information that we've got to help us understand rivers. So every overflow, so this is a real overflow on the right, it's not very clean like the one in the video, but that's quite common. Has like a sensor in it that measures the level in the chamber and keeps recording, and when the depth gets above a certain level, that's when we know it's having an impact or it's putting water in the river. These sensors, they don't at the moment tell us the volume of water or the quality of the water that goes out into the river. And there's lots of problems with data errors. So you can see in the example at the bottom, it might be real data, but I suspect that there's some strange things kind of going on here. Mainly because these sensors, they often get like debris on them and rags on them, so it kind of affects them for periods of time. So yeah, another type of data information that we have to understand impacts on the water environment. Okay, so that's, yeah, a bit about me, a bit about what river health is. So just going to give you, I promise it'll be a very short history lesson, because I know you're all studying engineering and not history, so probably not too interested. But anyway, I think it's maybe useful to just see why we started to worry about river health in the UK. Whoops, a daisy, that's the wrong one. And how it's changed over time. So we really started to worry about river health when it started to affect humans, basically. We didn't really care before that. So in the 1800s in the UK, there was something called the Industrial Revolution. So it's when there was lots of coal mines and metal manufacturing and fabric manufacturing. All of these industries started to really grow in the UK around that time. And because of that, people moved from farming kind of jobs to cities. And in the cities, they were really closely packed together. The quality of life was very bad. Lots of houses would share like one toilet all together, and generally people weren't very healthy. Around 1831, we had the first deaths in the UK from cholera. So that's like a bacteria that gets in your stomach. It causes vomiting and other nasty things. And lots of people started to die from this disease because even people who are really quite healthy, and the government was really worried. And at this time, we didn't really know how people got cholera, what caused it. Nobody really understood in 1831 what it was. So there was a lot of panic about it. In 1858, there's lots of evidence from newspapers of the time about the Great Stink. It's a bit of a stupid name. But lots of cartoons showing the River Thames, which is like the big river through London, showing it as this horrible kind of place of death and decay, this like really horrible, horrible place to be. So people were like, oh, this isn't great. Luckily, someone called Dr. John Snow, I didn't make that up, managed to work out from some data about deaths due to cholera that it was caused by people drinking bad water, so contaminated water. And kind of as a result of that work and some other kind of research, I guess, that happened at the time, eventually, 1875, so it took quite a long time for anyone to do anything, but the government introduced a Public Health Act, which meant that every city had to have sewers to take wastewater away and clean water supply to try to prevent all of these unnecessary deaths happening. And you can see on the right there's a picture of a sewer being built at the time by quite a famous engineer called Joseph Bazalgette. I don't know how you say that, never mind. And actually these sewers are still kind of in London at the moment and kind of more or less working. So that's kind of, we started worrying about river health because it was impacting on human health, and the government started to act. So through the 1900s, there was lots and lots of different laws, but I won't go into them in lots of detail, which changed how water and wastewater was managed in the UK. But I'm just going to go straight forward to today. So the most recent things that we've seen in the UK around river health are lots of citizens, which is kind of the theme of today, getting increasingly worried about river health. So they're not happy about storm overflows, angry about how often they're spilling to the environment. And they set up local Facebook groups, they set up local communities who campaign to make rivers healthier. And again, picking up on the data theme that's kind of coming through this, they're collecting huge amounts of data as well. So they're taking photos every time they go for a walk along their local river, and they're like, I don't like that. They take a photo of it and put it on things like Facebook. So you can see some examples on the right here from one community group. Some groups take samples and analyse them. They report animal sightings. So lots of passionate people in, passionate public groups who want to see their rivers improve. Go on one. And the second recent change, I think partly because the public are unhappy, the government has done something. So from 2021, they require water companies to put sensors in the river to monitor quality upstream and downstream of every overflow and sewage treatment work. So we're going to get more of this kind of time series data showing how concentrations of different pollutants vary over time. So another part of this kind of data puzzle that we're building up through the talk. Okay, so because I've been talking for so long and I want a break, I made a Slido poll to check if everyone is still awake. So if I go forwards one, this is where I may need Isaac's help again. I forgot to put the code on that slide, didn't I? Has everyone got the Slido working? Maybe that's the first question. Let me remember what the code is. You got it? Has anyone got it?
Yeah, there is.
Ah, there you go, perfect. Thanks, Isaac. So I'll just give you a few minutes. Can you all kind of, there's no wrong answer to this, that's probably important. I'm just interested to learn what you guys think are the most important skills or knowledge that we need to understand how healthy rivers are. I'll just give you a minute. I think it's working. Can I just ask, is that all of the front row, just out of interest, who's voted for hydrometeorologist? Yeah. No, you're voting for that. Cool. Stop changing. I'll let it get to 27 and then stop. Oh, 28. Is anyone still going? Or yeah, I'll give you a minute. Oh, it's probably my fault for doing it. I get a micro. Oh, there's too many things to hold now. Okay, great. I think it will stay open, the poll, so we can look at it at the end. It's very loud. I'll hold it there. Great. Yeah, so really interesting that those are your answers. I think it's all of these things. It's interesting communication wasn't one of the ones higher up, because I haven't voted, but if I was, I think I would vote that quite high, because I don't think there's any one person who understands everything about river health. I think you need all of these different skills, but also all those different people need to talk to each other and share what they know. So enjoying the answers. I'm convinced this is because we've got a row of hydrometeorologists in the front row and they've all voted. They've all voted for themselves, but never mind, that's fine. All good. Great, thank you everyone. It was interesting to see what your thoughts are about that one. How am I doing for time? I should check that. We're okay. Okay. Up. Oh yeah, brilliant, thank you. Right, okay, done that one. I think we've done that one. Why is it not playing? I'll try this one. There we go. Where are we at? Okay, so we've done me, we've done river health, we've done a bit of a history lesson. So now we're just going to talk a little bit about how we analyse river health in the UK at the moment. And again, just as a little reminder, not that you all need reminding, some of these methods are quite old, and I think we could do them better. So I want you to tell me how to do it better, basically. Tell me how to do my job. Okay. So essentially, there is a huge amount of kind of computer modelling that happens in the UK at the moment to understand river health. Generally, the models are kind of based on physics and chemistry, rather than being kind of machine learning or data-driven, anything like that. So let's start with kind of rainfall at the top. So we use different sorts of rainfall data to input into these different parts of the water cycle. So we might use radar data or rain gauge data, combination of the two. We might use sort of stochastically, like probability to work out what kind of rainfall is going to fall in a particular catchment. That rainfall might feed into a sewer model, a model of the sewer network, and I'll show you an example of one of those on the next slide. And that will tell us the flow through the overflows and to the treatment works. And some of the models as well, they allow you to understand what their concentrations are of different pollutants in the sewer network. Moving to the top, so we have like the treatment plant. Again, there's different ways that you can model treatment plants, from very basic models, which just take a flow measurement and some samples from the treatment works to represent the treatment works. Or at the other end, you can have quite a complicated process model that simulates everything that's happening throughout that wastewater treatment works. So different levels of complexity, but generally all based on some sort of physical chemical modelling. So that's that bit. Can I shout? This is really distracting me. Is that okay? Can everyone hear me if I just talk like this? Yeah? Do you mind? Sorry, I'm going to just put that over there. Can I give that to you? It's very loud in my ears. Is that okay? And then, finally, so the sewer model and the treatment works model might feed into a river model. And again, like with the others, this can be very simple. So it can just be kind of like a bucket. So you'll get flow from the sewer model and a concentration from the sewer model and a flow from the treatment works model and a concentration, mix it all together and just get like almost a fully kind of mixed system. It can be something kind of very simple like that. Or at the other end of the spectrum, you can kind of model the full river in sort of 2D, 3D, looking at the mixing processes that occur. So yeah, different levels of detail, but that's generally kind of at quite a high level how we understand water quality issues at the moment and decide where money needs to be spent to improve river health. Don't know if that made sense, but you can ask me if it didn't. Okay. This slide is an example of one of the sewer models that I mentioned on the previous slide. So this is the most kind of common software that we use in the UK. That's very small, but it's called InfoWorks ICM. And in it we build this picture of a city. These sort of little circles that you might be able to see, those are the manhole chambers. And different colours depending on what flow goes through them, but anyway. And then there's pipes that kind of connect them all together. These kind of hashed areas that you can see here, they represent the flow from buildings, or when it rains on the catchment, how much rainfall from that area gets into the sewer and how long does it take. And down at the bottom here you can see this pipe that kind of goes along, I think it's the seafront here. You can see kind of the pipes are represented. We've got some sediment here. So it's modelled in quite kind of a lot of detail, I guess. The sizes of the pipes, where the pipes are, how flow moves through them. We can do these graphs that kind of show at a particular location with this rainfall, how much flow is there in each pipe. So these models are really good. They're really powerful. They're used in a lot of the UK, but they take a long time to build, to set up. You need good data about your networks, and they take a long time to run. So Susanna can maybe help me here, but say for a normal sized city, it could be, 1 to 2 years maybe to set up, get all the data, build it, calibrate it. Obviously, it depends on the size of the city, but just to give you a feel for how long these models take. Does that sound about? Yeah? Yeah, yeah, to set up. So they're great, but they take a lot of time, and I think you can do better. Yeah, WRC, the company that I work for, we have kind of some software called Simpol that allows us to, in quite a simplified way, model the whole of the river catchment. So representing the flows from the urban areas, the flow in the river, maybe agricultural runoff and what comes out. So this is much more simple, it's like a, anyway, than this model, but it's just another approach to modelling performance. So that's, a bit about that. Okay, so hopefully that's given you a good background, but I think NTU, Lee Penn told me this pun works, but I'm not sure if it does. I just mean, how can you guys do it better? So just to finish off, and I have nearly finished, I promise, a couple of example projects about the great stuff that is happening at NTU and how it's helping us to understand rivers in the UK. So first of all, where's Chi-Ling? I feel like you should stand up and take a bow and patron, I saw as well. These guys have been absolute, so I think we should really clap them because they've been so fantastic. Sorry for embarrassing you, but these students have been absolutely brilliant on this project and we couldn't have done it without them. So I'm sorry if there's anyone else that I've missed in the room, but yeah, thank you both so much for your work on this project. So this was a project that we worked on from about 2020 on working with citizen groups, so Friends of Bradford's Becks, and then Taiwan Clean Water Association, I think is sort of the translation, to put water quality monitors in rivers, see what citizens can tell us about the health, see what we can learn about the health of the rivers with citizens. It's been a partnership between different academic institutions, industry partners, and yeah, I think we've really learned a lot. Hopefully, UK's been able to share a few things about water quality in the UK, and I think we've used a device called Waterbox, which was first developed I think in 2015, right? I think that's right, by Lass, and you can see kind of an image of it in the top right up here. I think this is the latest version, if I remember. Maybe you can tell me if there's been any changes. I think that's the latest version. So this is like a device that is relatively cheap. So I think, I hope I converted this right, but 24,000, 32,000 NTD. So normally these sensors cost like 3,000 to 4,000 pounds. So maybe like, I don't know, 5, 6, 7, 8 times as much as this device. And it allows us to measure sort of simple parameters like pH, temperature, conductivity. You can plug in different sensors depending on what you're interested in. What have I forgotten from this slide? Oh, the most important bit. The first water box, we installed it in the UK in March this year and it's still running, and you can see, I don't know if you can see it very clearly, bottom right here. So the sensors are kind of in here and the cable kind of goes up to a water box, which we've got kind of installed here. And this is one of the people from the local community group helping me to kind of install it and check it and keep it clean and things. So, really, so using some of your great skills in kind of sensor and device development, which we're a bit lacking in the UK, to help us better understand rivers in the UK. So, sorry, yeah. Yeah, that's all good. And here we go. This is just to show you the kind of, so we just got the one water box at the moment, but more are coming soon to be installed in Bradford. And through the project, we've developed, with your help again, kind of an app that allows us to view the water box data in real time. So different parameters like oxygen levels, ammonia levels, we can see kind of how they vary over time, whether they're acceptable, good, or they could be better. And we can compare kind of different locations along a river. So if you imagine you've got a network of these devices, you can maybe see how quickly pollution moves along a river, how dispersed or spread out it gets. Perhaps you can analyse the change between two monitors and see okay, well that means probably we've got a problem here that we need to look at in more detail. So yeah, another kind of way that we're working together, which has been really good. Yeah, we could talk for hours about that, but I'll just keep it short. So a good example, hopefully, of how you wonderful people at NTU can help us to understand river health in the UK. Last slide, I think. I might even be on time. Yes, I'm on time. Okay, this is a bit of a sneak preview. So I think next week, is that right? 26th?
Or maybe postpone for 1 more.
1 week, 2 weeks. Okay, so this is a project that, yeah, we're really excited to start working on new students with. So as I mentioned a little while ago, lots of citizen groups in the UK, they're taking photos of their rivers all of the time. But we analysing them at the moment, it's quite manual, so people have to look at them individually and say, oh, there's that problem, there's that problem. It takes time, and there's hundreds of thousands of these photos that are being gathered. So what I'm really interested to see is whether, with your kind of machine learning expertise, can we automate some of that analysis? Can we use it to see, like, the colours haven't come out so well in this, for which I apologise, but can we use it to see where the river kind of changes colour, where here there's like a bit of a black, which is looking better on that screen, but a bit of a kind of black area, which indicates there's like a fungus growing as a result of sewage. In this tree, there's all these bits of like debris and rags that are kind of hanging down, which is a sign that a storm overflow has operated in high weather. So debris comes from the sewer network, the river's high, it catches in the trees and then it drops down. So this is kind of a sign that there's maybe a storm overflow in this area that's causing problems. We've got, again, this is like an outfall pipe from a CSO with some rags on it. So, can we find those? And then signs of just not very nice litter, basically, in rivers as well, like trolleys, and I can't remember if that was a fridge or something ridiculous that someone had put in. So there's all sorts of different indicators that we can see in these photos of river health, and yeah, very excited to see what we can kind of work out together, if there's ways we can kind of automate this analysis. So just then, yeah, a bit of a summary at the end. These are some of the types of data that we've talked about today that we've got to understand rivers in the UK. So targets, compliance data, permits, overflow levels, water quality data, whether that's continuous time series or just samples, rainfall, sewer models, treatment works, all of these different types of things. And maybe we're not making the best use of them at the moment. Maybe there's smarter ways that we could be analysing this data. I think that's it, which I make almost, I think that was 38 minutes. So I think that's pretty good. So yeah, happy to take any questions if anyone's got any. Go for it. There is.
Any questions? Any questions? Or we want to wait for the second speaker?
All good?
I think we'll wait for the
Yeah.
second.
Do you want me to do anything? You got this.